Hello, welcome back. So if you watched the last two videos, you should be able to get this joke. I used to think correlation implied causation. Then I took a statistics class. Now I don't. Sounds like the class has helped. Well, maybe. So we talked about how correlation doesn't imply causation, but also in statistics you got to be careful before you assert something with a certainty. More than often there is a caveat. You would say it's likely to happen, or within this certain it is this probable that this event would happen, but you almost never say this exactly will happen. So that's a joke here. So anyway, so let's move on to the next. So here is a problem. So you have a graph. On x-axis you see total proteins. On y-axis you have the total fat. So the scatter plot above shows the number of grams of both total protein and total fat for 8 sandwiches in a restaurant menu. The line of the best fit for the data is also shown. So in the menu items, as the protein is increasing, so is the fat. So according to the line of the best fit, which of the following is closest to the predicted increase in the total fat in grams for every increase in 1 gram in total protein? So this is a tricky problem. But again, if you watched my videos on linear equations, how to interpret, it should be fairly straightforward. So what we're trying to do is for a unit change of protein, how much would be the change in the fat? So what do we need to calculate? So we really need to calculate the slope. So you can slope of the line. So you could pick any 2 points that are falling on the line and take the difference in y-axis and divide it with the difference in the x-axis, you would get the slope. But when you have a graph like this, it's best to try to go as far between two different points. So I would take the lowest point here and the highest point. Both of them are pretty much on the line, and calculate the slope using those two. So what is the y value in the rightmost point? So that seems something like 75, and on the bottommost point it seems like 15. So the difference in the y axis is 75 minus 15 is equal to 60. And how much is the difference in the x-axis between these 2 points? So something like 50 minus 10, 40. So 60 divided by 40, so the answer would be 1.5. So that would be our answer. So again, it's to know that the slope is the measure of how much the value on the y-axis changes when for a unit of change in x-axis. So remember, it's rise over run. So, and this is a concept that you should be familiar with. So let's look at one more problem. Which of the following graphs best shows a strong negative association between D and T? D is something that's graphed on the x-axis and T is graphed on the y-axis. So which of the following graphs shows a strong negative association? So positive means if one goes up, the other should go up, and a negative means if one goes up, the other goes down. So you look at A, seems like here there's hardly any relationship. As D moves up, you can't really tell that T is going up, it's all over the place. So it seems like there's hardly any relationship. Same thing with B. In C, we see a certain relationship. As D increases, so is T. But then that is a positive relationship. So we look at D. As D increases, T is as yeah, T is decreasing as D increases. So that is a negative relationship. But you may also note that it's not very clear if it is a linear relationship. It's maybe instead of a line, a curve would fit better. But either way, we know that it's a strong negative relationship. So D would be our answer. Hopefully these were helpful. Again, do watch the video on the linear relationships for some more examples, because I didn't want to do too many of them. It would just be a repeat. So good luck. And if you like these videos, please subscribe, and also share with your friends. Thank you.